In this flick, we resume learning more about the properties of pure substances. I will demonstrate how to use property tables to determine the thermodynamic properties of pure substances. A property diagram helps us to understand the variations of properties during phase change processes. The temperature volume and pressure volume, or we usually call them the TV and PV diagrams, for pure substances in thermodynamics are typically used. Recollecting the previous video, where the phase change process of water at 1 atm pressure was sketched on a TV diagram. If we could repeat this process but now at different pressures, we could develop the TV diagram as shown, where the numerical values are for water. The process can be repeated by adding or removing weights on top of the piston until the cylinder's pressure reaches the intended values. To demonstrate this, let us add weights on top of the piston until the cylinder's pressure reaches 1 megapascal. The pressure of 1 megapascal on a TV diagram is shown. As heat is transferred to the water at this new pressure, the process follows a path that looks very similar to the process path at 1 atm pressure. But there are some remarkable differences. The differences that can be seen are: water starts boiling at a much higher temperature of 179.9 degrees Celsius. The specific volume of the saturated liquid is larger and the specific volume of the saturated vapor is smaller than the corresponding values at 1 atm pressure. That is, the horizontal line that connects the saturated liquid and saturated vapor states are much shorter. As the pressure is increased further, this saturation line continues to shrink. It becomes a point when the pressure reaches 22.06 megapascals for the case of water. This point is called the critical point. It is defined as when the saturated liquid and saturated vapor states are identical. Suppose we could explode the previous TV diagram to zoom in to the critical point section. In that case, we could obtain the temperature, pressure, and specific volume of a substance at the critical point. These properties are called the critical temperature, critical pressure, and critical specific volume, respectively. The respective critical point water properties are shown in the given picture. The critical properties for various substances are given in Table A1 in the Thermodynamic book's appendix. The saturated liquid states and the saturated vapor states in the previous figure can be connected by a line called the saturated lines. These two lines meet at the critical point, forming a dome. The lines are the saturated liquid line and the saturated vapor line. All the compressed liquid states are located at the region to the left of the saturated liquid line, called the compressed liquid region. All the superheated vapor states are located to the right of the saturated vapor line, called the superheated vapor region. In these two regions, the substance exists in a single phase, a liquid or a vapor. All the states that involve both phases in equilibrium are located under the dome, called the saturated liquid vapor mixture region or the wet region.